Hi everyone, my name is Aditi, and I'm really excited to be talking about something that I'm really passionate about at Wonderfest. Before we begin, I would like to share a little bit about myself. I'm a tech lead at NVIDIA, and I'm leading the development of our foundation AI model for time series forecasting, classification, and anomaly detection. I also have a software engineering background, and I've dabbled in various other technologies as well, apart from just AI and machine learning. Beyond my core work, I also actively mentor early in career engineers and participate in tech reviews. So, before we go deeper into the world of foundation AI models and their application across modalities, I just wanted to talk a little bit about everyone's favorite foundation model called ChatGPT. I'm pretty sure most of you have used ChatGPT by now. It has become an integral part of some of our lives. But have you ever wondered how something like that was built? So that's where the foundation models come. ChatGPT is actually a type of foundation model called LLM foundation model. And it's not just ChatGPT or LLMs that can be foundation models. Models are just more than just LLMs. And that's what we are going to talk about today. So foundation models, how do you identify a foundation models? These are large scale pre-trained models which are trained on really massive amount of data sets, and these are like generalized in nature. For example, when you usually build a machine learning model, you have an end goal in mind, and that model can only work on that one specific type of data set, and it can only adapt to that specific type of data set. But foundation models, they are very generalized in nature. For example, if a foundation model is, let's say, time series model, it's so generic that it's able to consume large amount of time series data no matter what the industry is. How do you identify a foundation model? So one giveaway of a foundation model is that they are built on really large training data set. It's capable of handling unseen or cross domain tasks. For example, even if you have given it some very random data set, it's able to identify the patterns in those data sets and perform the intended function. These models, sometimes what happens is, because these models are generic in nature, you might not get the desired accuracy out of these models. So that can be fixed pretty easily. All you have to do is fine tune these models using whatever data set you want them to work on. Also, they have very generalized architecture. Most of them are based on transformer variants. So transformer is a type of model building architecture which kind of encodes any kind of data that's coming into it and decodes it. When that process of encoding and decoding happens, that's when you start getting outputs out of these models. So, as I said earlier, these foundation models are just more than just the LLM models. They are not always generative in nature. They can have different type of functionalities. And I think some of the common foundation models that we are already familiar with are ChatGPT, Bird, Llama, of course. But other than that, there are other pretty popular foundation models out there. For example, for computer vision space, you have Clip, Dino, SAM. Then for time series, NV Tesseract is not the only time series model that's out there. We have Moment, Time GPT, Chronos, and even the code assistant. Like, I think a lot of you who are into software engineering are already using these code generating models. For example, Cursor, Copilot. I think Copilot is a more popular one, but yeah, we have Claude. So you can use uh, you can find functionalities across different domains for these models. Some common use cases for foundation models are in natural language processing. This is probably the most common use case that you can find for them. They do language translation, they can do generalized sentiment analysis. You can create chatbots using these models, and it can even generate content like you must have seen on Instagram or whatever social media you follow, that these days people are using that Ghibli filter where they are converting their images into Ghibli like images. It can also write poems for you. Many people use it to write their emails these days. But apart from NLP, we find a lot of use cases in scientific and industrial applications, including healthcare, discovery, autonomous vehicles. Um, Waymo is a very good example. If you ever visit San Francisco area, I think almost every single person who lives there has tried out a Waymo. I recently went to Phoenix and there were Waymos everywhere. So, like apart from self-driven cars, these models are pretty useful in industrial data analysis too. For example, in factories, if you have to detect if something has gone wrong in their sensors, or if you want to ensure if the data is getting collected correctly, you can use foundation models to do that. Of course, computer vision. This is like one of the pretty common use case that we come across for foundation models. These can be used to, one, generate videos, generate images. They can also be used for high resolution image creation and editing. You can use the foundation models for analyzing videos. And apart from just these common, yeah, domains, we have a lot of emerging and specialized domains. So specialized domains are where you are trying to identify use cases for really niche tasks. One such good example would be chip building, because I'm from NVIDIA. So, so you would not believe, but a lot of chip building industries are adapting foundation models to ensure the quality of their product is really high. They're also trying to, they're also very useful when you're trying to innovate or when you're trying to simulate different factors while building something in factories. So, because I work on time series foundation model, this is something that I can really talk about, and I really wanted to expand on it a little bit, because I think anything that we do in this world is actually a time series. Anything that can be time stamped, anything that happens in a sequence is time series data. So you'll find time series data everywhere, whether traffic data, sale data. If you're trying to follow somebody's journey or some product's journey, then also it's time series data. If something is getting manufactured, then you are recording details about that product. That's also time series data. When so the data that's time series is abundant, but the real challenge comes when you're trying to consume that data to get anything out of it. And we took that as a challenge and decided to build a foundation model that will hopefully translate across all these domains. And then that's how the idea of NB Tesseract was born. Now, there's a large difference. So, you would ask me, Aditi, why do we need to make a really large model when we can just make a smaller statistical model for the specific use case? You can, no problem in doing that. But if you have the compute, and if there's a chance that your use case will expand in future, you'll not just be dealing with that one specific time series, then foundation models are also really a really good idea to make, because once you have pre-trained a foundation model, it can be used across different industries, different modalities. All you need to do is follow the same steps, but just fine tune that foundation model. And the difference between statistical model and foundation model is that its foundation model is more complex. It directly learns patterns from the data. You don't have to do a lot of data processing for that model to understand the patterns in the data. Feature learning and is automated. You don't have to do feature selection on your own. The models, a lot of foundation models can actually extract the highly correlated features from the data. And the foundation models can also handle unstructured data. So basically the only requirement for foundation models is the data modality. Like if it's an LLM, it would expect some kind of text data. If it's a time series foundation model, it will expect some kind of a time series data. Now, because I'm from NVIDIA and we have a lot of foundation models, we support building of foundation models, and there are a lot apart from the more popular ones like Nemotron Llama, which is actually a wrapper around the Llama models. We also have a lot of other foundation models that are spread across industries. One of the more popular ones is Cosmos. So Cosmos, it generates physics aware video world. So we usually use them to create digital twins. And the applications for a model like that, it has a lot of implications. Like you can use them to simulate what a factory layout would look like, or if you're building something smaller like a machine, you can first simulate what the machine infra would look like, what it would look like once you have assembled it completely. Apart from that, we have another foundation model for segmenting and annotating human genome. So these type of models are really useful in healthcare spaces, or wherever DNA analysis or any kind of genetic analysis is taking place. And the third one, which is my favorite, it's Evo 2. It's a biological foundation model that lets you that is able to integrate information over long genomic sequence, and it can help you simulate a lot of things. Like it's very useful in drug discovery based tasks. It's very useful when you're trying to understand how a new antibody might be affecting um, the clinical trial patients. And these are just like few models that NVIDIA has. Apart from that as well, there are different other models that are under research, for example in autonomous vehicle space, time series space, and not just NVIDIA. There are a lot of other organizations that have done research in foundation model space, and it's a really fast evolving field. So I think we are on time, and that is it. Feel free to reach out to me if you have any questions about this really interesting and evolving space of foundation model buildings. And yep, thanks a lot for listening to my presentation, and have a nice day.